to create a new ecological Gehu lake featuring the integration of blue waters and green landscapes with shimmering scenic beauty. The Wujin district of Changzhou launched the Gehu Lake Wujin Ecological Dredging Pilot Project. Located in the southwest of Wujin district, Changzhou Gehu Lake covers a water area of 144.1 square kilometers, making it the 6th largest lake in Jiangsu province and an integral part of the Taihu Lake Basin Lake Cluster, with a dredging volume of 712,000 cubic meters. The project adopts an ecological dredging combined with geotextile tube dewatering and drying process. Supumps Environmental Technology, Changzhou Co., Ltd. is responsible for the construction of the geotextile tube dewatering and drying works. Project preparation. Site survey. Upon receiving the project mandate, the Supumps engineering team conducted a comprehensive site survey covering project site conditions, construction constraints, dredging volumes, effluent discharge requirements, dried sludge disposal methods, and project schedule. Process pilot test. Sediment samples were collected from various points in the dredging area to conduct dewatering and drying pilot tests, confirming the chemical type and dosing ratio, as well as geotextile tube filling experiments to determine the optimal tube specifications. Scheme development. Based on the survey findings and pilot test results, the Supumps technical team conducted process evaluation and developed the construction scheme, balancing economic and technical feasibility. A 3D animation was also produced for this project to provide a more intuitive presentation of the overall project. Construction mobilization. To ensure project objectives are met, prior to mobilization, a 5-party briefing was conducted, covering the construction scheme, safety schedule, and quality requirements. The project officially commenced in April 2022, with an expected completion in April 2023. The total construction period is 1 year, with the geotextile tube dewatering and drying phase lasting 6 months and a daily dredging volume of 6,000 cubic meters. Upon meeting the mobilization conditions, our engineering team was organized to enter the site in an orderly manner. Sediment disposal site construction. According to the design scheme, the sediment disposal site was located approximately 5 kilometers north-east of the Gehu Lake dredging area, south of the Huwu Expressway, and east of the July 1st Farm, covering an area of approximately 109,000 square meters. The site was graded with a 1% slope, with side ditches and equalization basin, and an effluent pond excavated, and an impermeable geomembrane installed. Equipment and material mobilization. Geotextile tube layout, online treatment equipment, materials, and piping were mobilized and installed, and geotextile tubes were laid out. System commissioning and trial run. Equipment and piping underwent system commissioning and production trial runs. Filling construction. According to project requirements and site conditions, the site was divided into 2 sediment disposal areas, with a total of 205 first layer and second layer geotextile tubes laid. Effluent discharge. As Gehu Lake belongs to the Taihu Lake Basin, effluent quality must exceed the pollutant discharge standards of the Taihu Lake Basin. To ensure compliant discharge, we implemented timed monitoring of the effluent, self-inspection every 2 hours, daily inspection by the supervision party no less than 4 times, and weekly inspection by the owner no less than 1 time. Additionally, we conducted third-party inspections no less than once per week, while the supervision party and owner conducted third-party monthly inspections no less than once per month. Process features. Sludge intake. Salvage vessels are first used to remove debris from the dredging area. The river bottom sediment, suctioned by an eco-friendly cutter suction dredger, is transported via temporary lie-laid floating discharge pipelines to the screening well at the drying site. A rotary bar screen is used for debris separation, removing hard and flexible waste from the slurry. The screened slurry then enters the equalization basin for flow and concentration regulation to reduce impact on downstream units. Online treatment. The equalized slurry enters the online treatment equipment, utilizing the cavitation method principle to achieve rapid and efficient mixing of slurry and chemicals under continuous feeding conditions. The system can automatically adjust chemical dosing in real time based on incoming slurry volume and solids content to achieve optimal solid-liquid separation. The entire process is automated and requires no dedicated personnel. Filling and dewatering. The chemically conditioned slurry is pumped via a cutter suction pump into the geotextile tubes. The conditioned slurry exhibits significantly improved settling performance. Inside the geotextile tubes, solid liquid separation is achieved through self-gravity, with over 99% of solids retained within the tubes, while the filtered effluent is discharged to the effluent pond. After 2 to 4 weeks, the solids content of the sludge inside the tubes can reach 45% or higher. Effluent. The effluent filtered through chemical treatment and geotextile tubes is clear and transparent. The pH value is unaffected, while suspended solids and total phosphorus are significantly reduced, meeting design requirements and allowing direct discharge to the original water body. Dried sludge utilization. Depending on the soil quality of the dried material and actual requirements, it can be used as ecological building material for landscaping and planting, or transported off-site for disposal. Process advantages. Small footprint. Single-layer geotextile tubes can achieve a filling height of at least 2 meters and can be stacked in multiple layers according to actual conditions, reducing land occupation. Alternatively, the dried sludge can be transported away, freeing up space for cyclic site utilization. No secondary pollution. After reaching the drying cycle, the sludge volume is significantly reduced with high dryness. If off-site transportation is required, costs are reduced, and there is no leakage during transport. The effluent quality is excellent, causing no secondary pollution to the surrounding environment. Low energy consumption. Inside the geotextile tubes, slurry dewatering relies on self-gravity, requiring no additional kinetic energy during the dewatering process. High efficiency and short schedule. The cutter suction dredger has a large single-vessel dredging capacity. The online treatment system can achieve solid liquid separation under continuous feeding conditions. With large throughput and high efficiency, geotextile tubes offer substantial capacity redundancy, enabling simultaneous dewatering of large batches of conditioned slurry with excellent solid-liquid separation and short dewatering times. This is particularly suitable for dredging projects with tight schedules and large volumes. No odor pollution. The geotextile tube dewatering process is fully enclosed, effectively controlling odors. The Gehu Lake Wudgeon Ecological Dredging pilot project has garnered significant attention from government leaders and industry experts, receiving on-site inspections from central, provincial, and municipal leaders. At the Water Environment Biweekly Forum, themed Healthy Rivers and Lakes, over 100 industry experts and scholars exchanged ideas and discussed topics related to Gehu Lake water environment governance. Furthermore, the project has been reported by media platforms including Changzhou News, Shupengshi Environmental Technology, Changzhou Co., Ltd will take the Gehu Lake Wudgeon Ecological Dredging Pilot Project as a new starting point. Continuously summarizing experience in geo-textile tube dewatering and drying projects, and developing technologies for geo-textile tube underwater filling cofferdams, ecological wetland reed, planting and harvesting, and co-processing and utilization with cyanobacteria, embracing the concept of circular economy. We will devote ourselves wholeheartedly to large-scale river and lake dredging, drying and ecological governance projects, such as Gehu Lake and Taihu Lake. We will carry forward the fearless ambition of daring to be pioneers and the vigorous momentum of forging ahead, ensuring survival through project quality and seeking benefits through management services, riding the wind and breaking the waves, standing at the forefront of the tide. We will strive to become pioneers in river and lake ecological governance, painting a new chapter of harmony between humans and water.